Recursion. What is recursion? Recursion is the process of a function calling itself within the function. Much like a loop, a recursive function will run a portion of code repeatedly until it reaches a certain condition. In a loop, the condition is defined in the definition of itself, but in a recursive function, the condition is defined within the body of the function. A recursive function has two parts. The composition of a recursive function. The condition that causes the end of a recursive function is the first of the two parts, and it is called the base case. The base case is used to stop the cycle and causes a return statement to be run, which will end the process of recursion. The second part of a recursive sequence is the recursive call. The recursive call is a part of the function body that calls itself. The recursive call needs a way to get closer to the base case with each recursive call. Otherwise, it will never reach the base case and will be recursive forever, which is a problem. Here's an example. This function is for summation. This means that any number inputted plus every number down to 0 is what it will output. It accepts one integer as an input. Because this is a recursive function, the first thing we do is we define the base case. In this case, it says if n equals 1, what we do is we return 1, and this will be the end of the final function. The other part of our if statement, the else statement, is the recursive function. It states return n plus summation of n minus 1. This portion of the function is called the recursive call because we are calling summation within summation, and this is what makes it recursive. Now, in this case, n is added to summation of n minus 1, and the reason it's n minus 1 is because it gets closer to the base case each time recursion takes place. This makes it so it is inevitable that the base case is reached and the function will end. While this seems quite simple, it actually relies on the continuous calling of summation until we reach the base case. Here are some videos of me running the function with the numbers 1 through 5. Notice how from the previous call, only the new n value is added. This is because the previous ones are actually being run under the hood of the subsequent call. Here is a list of the function calls with their inputs and their outputs. I will walk through summation 5 in order to showcase the way the function actually operates. In order to explain what summation 5 is doing, we have to understand what summation 5 is comprised of. So, we know that summation of n equals n plus summation of n minus 1. So when 5 is our input value, we know that summation of 5 is equal to 5 plus the summation of 4. We must note that unless we have the value of summation of 4, this doesn't help us. But because summation of 4 is our recursive call, we go into the summation 4 before we are able to finish summation 5. Summation 4 is equal to 4 plus the summation of 3. The process repeats. Summation of 3 equals 3 plus the summation of 2. Summation of 2 equals 2 plus the summation of 1. But once we reach summation 1, we know that our base case, because n equals 1, will just return 1. Because summation of 1 equals 1, we know that summation 2 is able to finish because it's 2 plus 1, which returns 3 if we look at our table. And then summation of 3 returns 6 because we know that summation of 2 is 3 and 3 plus 3 is 6, which returns to summation 4, so on until we go up the table until we get summation of 5 equals 15. So that was pretty quick, and I understand there's a lot of moving parts, so it's kind of difficult to grasp, especially at first. But just know that in order to get summation 5, you need summation 4, and in order to get summation 4, you need 3, and in order to get 3, you need 2, in order to get 2, you need 1, and 1 is the base case, so you always have it, and that's what allows everything to spring back up to the top and have that output as summation 5 equals 15. Considering the size of the body of the function, there is a lot going on under the hood. Without a doubt, recursion is a confusing computer science concept, so why use it? Through recursion, we are able to break down big problems into smaller problems and solve them individually. In summation of 5, which outputs the sum of all numbers under 5, by writing a simple program, we are able to calculate up to 5 by calculating 4 and 3 and 2 and so on. For solving small repetitive problems, recursion is a very concise way to write a solution to a problem, as long as you understand how to break the large problem down into smaller parts and reach a base case using the same algorithm.